Hello everyone, good evening. So finally the last presentation of the day. So I am Gaurav, I work for Ericsson and unfortunately other folks couldn't make it to the presentation, so I'll walk through this. This idea was collectively explored by all 5 of us. So it says adaptive SDN networks. So basically this is based on the OpenFlow spec 1.4 which has some of the really cool features which we can use and make the SDN networks more optimized or adaptive. So we'll go through all these 3 features of 1.4 and see how these can be utilized to make the network more adaptive. So the basic introduction, the SDN makes it more flexible for the application layer, but there's still a chance where we can make a controller layer to know more about the underlying layer. So if the controller layer knows more about the underlying layer, the application will have a better go at diagnosing the underlying layer. So it says this proposal makes use of OF 1.4 specification enhancement, which brings in the optimization to the network. So what is the limitation in the present approach? So the limitation is the controller layer exposes the underlying network structure to the apps, but there is a scope where we can do a continuous diagnose to the network infrastructure layer, and these particular elements or these particular diagnostic result can be used by the controller to make the underlying layer more optimized. How this can be done, we'll explain or we'll go through the features exposed by the 1.4 spec. But before going into that, let's see the limitations in the form of the use cases. Use case 1 can be when we have too many flows, meters or group requests going down to the switch. So if one fails, everyone has to roll back. So this is a use case 1, then where the controller has to reprogram all the flows, group and the rules again. The use case 2 can be there are flows which are staying in the switch, but they are never being hit and they are just consuming the table space. So there are mechanisms by which we can remove those flows and get the more higher priority flows go down to the switch. So that was the limitation which we'll be solving, and how we'll be solving this. This can be solved by using these 3 basic enhancement which is provided by the OpenFlow 1.4. It's not necessary that we should have 1.4 compliant things. It can also be achieved by using the experimenter framework. We'll get back to that, how that can be done. But for now we'll go through all these 3 particular enhancements which will help us in making the SDN network more optimized or adaptive. So we'll go through the bundle mechanism first. What does a bundle mechanism say? It says you can group all the particular flows or the particular OpenFlow messages in a bundle, and that bundle will have a particular bundle ID, and with that bundle ID you have a message, bundle add message, which can encapsulate the number of flows, group or meter or anything. And not only that, this can be validated before provisioning it to the switch. Once these are validated, the controller gives the switch a green signal of a commit message, and these are committed. So either all are committed or none is committed. So this way you are breaking the complexity application wise. So one particular application has certain flows that can be clubbed into a bundle with a bundle ID, push it down, verify it and push it down. If the particular flow fails, only that application doesn't work and only that application is rolled back instead of entire thing getting rolled back. So this is a sequence diagram for explaining the same thing. So how does it work? Controller starts with the open request with a unique bundle ID, and then this add message, OFPT bundle add message will have all the OpenFlow messages encapsulated. Once these are done, they are stored in a temporary staging area inside the switch, and then these are getting validated. Once they are validated, this bundle is closed with a bundle, so same bundle ID, and then everything is done. Finally, the controller says it's all fine. You can go ahead and provision the flows. So finally, this set of flows or the set of open flow rules get provisioned into the switch. This is another way of looking at the same thing. So this will give us a idea of how the errors are handled. So you open the bundle message with the ID, send in the add request, and any error you roll back to the controller with a particular response. No, save it in the staging area. Close request fine. Go back to close request is received. If there is no problem in that, you do a commit. If there is a problem, we go back and roll back to the controller. So now we'll see the second enhancement from 1.4 spec, which is eviction algorithm. So this particular sequence diagram will explain what the eviction algorithm does. So basically, when the controller states about the table description feature, table mod message, it states a property which is eviction. This will let the switch know that the controller wants to enable the eviction property on the particular table or a switch. In reply to this, the table description message from the switch will let the controller know the way in which the eviction will be performed. So this eviction is basically a switch specific property where switch can decide on which way this eviction can be performed. One way can be the flow mod. OpenFlow 1.4 spec says there is a short value which can be added to a flow structure which says importance of a flow. This importance is different from the priority. So based on this importance, we can evict the particular flow from the switch. We'll get to see more on this importance flag. So this is just a description. So if earlier than 1.4, the table had a finite capacity. So even if with that capacity, if the table is full and we try to push in the flow or any open flow message, it throws a error. So this can be a tedious task, reaching that point and then clearing up the space in the switch and then re-provisioning it. So instead, eviction algorithm help us in doing that. In the table message which goes from the controller, table mod message which goes from the controller, we enable a flag saying we want to perform a eviction, and switch honors that request, and switch tells on which basis we can perform the eviction. So these are the particular ways in which switch can perform. One can be the importance flag. Based on the importance flag, higher the importance, the lesser chance of the flow getting evicted. And other thing can be the hard timeout or the idle timeout. Based on that, the nearest expiry period will be taken into the consideration, and based on that, the flow will be expired. Apart from this, switch can itself has their own algorithm of evicting it. It can be a switch specific. So these are the various these are the flags which is sent by the switch that I will be performing the eviction based on this. This can be set together or all of three together. Based on that, switch implementation will take care of which particular property is used first or the last. So finally, the third property from the 1.4 spec, which will be useful in making our SDN network more adaptive, is the vacancy event. So this is the notification which comes from the switch when you reach a particular level of table size. So same way, when the table mod property, we set the value for the down and the up vacancy value, that if this particular values are reached either up or down, switch will send me a notification which is table status. Reason will be one of this either down or the up value. So based on that, we can get the early warning on table is about to get full or situation like that. Once we get this situation, we can remove those flows which are not getting hit using the previous eviction mechanism, and the more priority flows can go in. So this is the description. So we send down a table mod request stating the vacancy down and the up value from the controller, and if any of these value is reached, we get a notification from the switch stating that this particular down or the up limit has been reached. So this says the again same thing. So now we know the 3 basic constructs or 3 basic enhancements of 1.4 specifications. So how to use these enhancements from 1.4 to make the network more adaptive or optimized. So we'll go back to our use case 1 and use case 2. Use case 1 is solved much by the bundle mechanism, where you don't rely on entire flows or a group. Rather, it's more on application based. Particular application is rolled back or particular application is a success. Other than that, the other use case was when you had so many flows which are not getting hit, but they are simply taking up the table space. That can be used. That can be solved using our other 2 constructs, which are eviction and the vacancy events, where you get an early warning from the switch that the table is about to get filled, and you can go ahead and remove the flows which are not getting hit, and you can provision the more important flows. Since OpenFlow 1.4 needs support from switch also, so it's not like we need to have 1.4 only, then only we can have these particular enhancements. We can do away with all those using either the hard timeout or the idle timeout value in case of vacancy event, and also it can be done by the experimenter data, or the importance flag can be augmented to the flow mod message. But if these are done, we still need a switch support from the switch. So a switch should understand basically all these constructs. So if this particular thing is been realized in the ODL framework, these are the particular modules which will get affected. FRM for sure, switch manager, and there will be a new module which will be having this all the features. A 1.3 plugin, since all the constructs will go down through plugin, and finally the switch. So what are the advantages of having this all 3 enhancements, and how this is making our SDN more adaptive? So this bundle mechanism gets a better transaction management capability. Vacancy and eviction methods provides a much more better notification support from the switch and early warning from the switch in the crisis of the table full or other stuffs. Finally, so the essence, the basic idea behind this proposal is to make use of the new or the cooler features of 1.4 specification and make the underlying layer talk to the controller layer more rigorously, and based on that, the application, the important flows don't have to survive or wait for the wait in the situations of table full and etc. So this will make our network more adaptive and more optimized, and that's it.